Next, let's talk about vector subtraction. Now, we're going to start with the geometric interpretation, and I'm going to draw a triangle of vectors very similar to what I drew with vector addition. So let's say we have vector v here, and let's say vector u here. And let's call this vector here vector w. Okay? So using what we know about the geometric intuition of vector addition, because vector v and vector u are drawn tail to tip, if I take vector v and add vector u, I will get vector w. Right? So what we can do here is we could just subtract one of the vectors to the other side, and that will tell us the geometric interpretation of vector addition. So let's take vector v here, and let's move it to the other side of the equation. And therefore, vector u represents what we get when we take vector w and subtract vector v. Okay, so vector u here is what we get when we take w minus v. So let's give an interpretation to that. Let's put that interpretation in words. Okay, notice that we're drawing things a little differently here with our vectors v and w and v. V and w are both drawn with their tail at the same position. U has its tail at the tip of vector v and its tip at the tip of vector w. Okay? Notice where u ends up. The end of u is at the end of w. And the start of u is at the tip of v. So because of that, I'd like to think of vector subtraction as end minus start. The resulting vector you get when you subtract two vectors ends at the tip of your first vector and starts at the tip of your second vector. So end minus start. Okay? Notice here order is important. If I did this the other way, if I did v minus w, if I looked at v minus w, then I would end at the tip of vector v. I would start at the tip of vector w. Okay, so I'd get, and let me make this a little bigger just to distinguish it. I would get this. Okay, because now I'm starting at w, and now I'm ending at v. End minus start. That'll help you remember the order of this. Okay. The actual computation is what you would expect. If let's let v equal v1. I'll give myself a little more room here. v1, v2, all the way to vn. And let's let w equal w1, w2, all the way to wn. Then, if I want to subtract two vectors, w minus v, I just subtract their corresponding components. So first component of the first vector here minus the first component of the second vector. So w1 minus v1, second component would be w2 minus v2, and so on. And the resultant vector can be drawn with its tip at the tip of vector W and its tail at the tip of vector V, if V and W, let me put it this way, if the tails of V and W are drawn from the same position. Okay,